This is lesson 5 of chapter 2. In this lesson we'll talk about the states of matter, also called phases of matter. In other words, solids, liquids, and gases. So we'll begin with gases. You may be aware of some of these concepts, so some of this may be new though. So with gases have no definite volume and no definite shape. If you were to release a gas, maybe after a good dinner, the gas would actually spread out to every portion of the room, and you could not measure its volume. It wouldn't have a set volume. By definite, we mean like a set, known. And then it has no definite shape. It just kind of goes everywhere. And that's because the particles in a gas, now remember, particles are just little tiny pieces, little tiny units, little tiny parts of something. Particles are very far apart and are in very rapid motion. They're constantly moving. So if you were to take this off, particles would just go everywhere. So gases are completely free to move. In the case of liquids, liquids actually have definite shape. Have definite volume, but indefinite shape. So you can measure the volume of a liquid. In fact, you can pour it into a container and then measure how much of that you have. But if you tip the container over, the liquid falls out, pours out. It does not keep its shape. That's why it has an indefinite shape. The shape is different if you turn the container sideways. The particles in liquids are touching. In fact, they are bonded to one another. They're connected to one another, but they can still move and slide past each other. So that's why they have an indefinite shape for a liquid. In the case of a solid, then, they have both a definite volume and a definite shape. So you can definitely measure the volume of a solid, but you can also check its shape. Its shape does not change, say, if you tip the container over and pour the solid out. The particles are very closely packed together. They're stuck to one another. They're connected. But they do have motion, and their motion is vibrational. In fact, if you think about a cold piece of metal and a hot piece of metal, what is the difference in the particles? Well, the hot piece of metal vibrates faster. It also expands a little bit. That's why you see these particles a little further apart from each other. But the hot particles vibrate faster. The cold particles, not as fast. The cold particles still vibrate. They still move, but not as fast. And that's the difference. Let's quickly take a look at density, since in this chapter we've been talking about density. What do you think is the density of these three phases? We should see that the gas is the least dense. You have the least mass, least particles per a given volume. And then the liquid is much more dense than the gas, and the solid is even more dense. Notice how the solid is much more packed. This liquid has spaces, that are open, which means it's less dense. Usually, the solid is the most dense and the gas is the least dense. However, there are forms of matter that this rule is not followed. A very famous example is water. In water, since ice floats, the solid portion of water, or the solid phase of water, which is ice, is less dense. That's why it floats in water. In fact, an iceberg is mostly underwater, and a little bit of it's on top. So about 90% of an iceberg sits underwater, about 10% of it sits above, and that's because ice is about 10% less dense than water. And the reason this happens is because anytime water forms a solid, there are pockets of space that open up between the particles. So the particles are much more scrunched, much more mixed, closer together when in the liquid phase versus when in the solid phase. This also happens with some other substances, but it is the most famous in the case of water. There is a fourth state of matter, and this one we're not going to deal too much with, but we should mention it, and that is called plasma. And in plasma, what you have is you have matter undergoing a strange change. You have atoms losing their electrons. Now, we haven't discussed electrons yet, but just think about the atoms actually being torn apart a little bit. And this causes the substance to glow. And an example of this is found in stars. This is why stars glow or shine, because there's a bunch of plasma on the star. Anytime lightning hits, what you see is a bunch of plasma. The air actually gets heated up so hot that you see plasma for a little bit. The electrons come off of the air particles. We also have technology like a plasma gun to cut metal and do other things. So we actually have use for plasma, the fourth state of matter. In general, we should say that the energy associated with a phase, so here it says the phase a piece of matter is in depends on how much energy it has. So how hot it is. Solids then have the least amount of energy, and then liquids a little more energy, and then gases have the most energy of a given substance, which makes sense. The particles in a solid are close together, they cannot move as much, and a gas they move much more. So this is true of any substance. Let's go ahead and review the phase changes. You may be aware of these phase changes. Let's do them together here. Melting is what we call anytime we go from a solid to a liquid. Freezing is the opposite, going from a liquid back to a solid. Those should be known to you. Vaporization may be new. Vaporization is going from a liquid to a gas. So, for example, whenever water is boiling, you go from a liquid to a gas. Now there's another phase change that's similar called evaporation. Now evaporation is actually different from vaporization in that evaporation usually happens at room temperature, whereas vaporization happens at the boiling point of the substance. And for our purposes, these two can be thought of as the same thing, but technically there is a difference. You have to be at the boiling point to call it vaporization, but water can evaporate just sitting on the table, and that's the difference. The opposite of vaporization then is condensation, which is going from a gas back to a liquid. And the last two are sublimation. Sublimation is going directly from a solid to a gas without passing through the liquid phase. This famously happens in a substance called dry ice, which we'll show you in class. And dry ice misses the liquid state altogether. And last one, deposition. Think of the word deposit in here. Anytime something deposits, it goes directly from a gas down to a solid. Now deposition can actually be seen in the wintertime anytime there's frost forming on the window pane. So if you see little frost snowflakes on the window pane, if you look close, those got there from the water vapor in the air going directly to a solid. If it were to pass through a liquid phase, what you would see is you would see frozen droplets of water on the window, but you see solid, or you see the snowflakes because it underwent deposition. So all 6 of these, you should have these memorized. Make sure you know which is which and be able to recite them. Lastly, let's talk about the energy changes associated with the phase changes. So anytime you go from a solid to a liquid to a gas, you're increasing in energy. These are what we call endothermic processes. So thermic, this portion right here, means heat. Thermo means heat. And endo actually means into. So heat is going into the substance. Anytime you want a solid to become a liquid, you have to heat the substance up. You have to put heat into the system for it to liquefy. And then same thing if you want it to become a gas, you have to heat the liquid and put energy into it in order for it to become a gas. This we call an endothermic process. And each time bonds are being broken, so if you have molecules that are stuck together in a liquid, then you keep heating them up and they break apart, you're breaking bonds. And in order to break bonds, you have to put energy into the system, which is logical. If 2 people are bonded together, holding hands, if you want to separate them, you've got to put energy into them. And the opposite of this is called exothermic. Anytime you go from a gas to a liquid to a solid, heat is being released. That's because gas particles are moving much, much faster than liquid particles, and in order for them to slow down, they have to get rid of the heat that they had in them. We call this exothermic, exo meaning exit or out of. Actually, the best way to remember it is to think of exit associated with exo. So heat is exiting the system. And anytime bonds are formed, heat is given up. Heat is released. So hopefully this makes sense. Go through the lesson again as needed. But this concludes for us lesson 5 of chapter 2.